In this problem we have what is known as a bridge circuit, and we have the loops as indicated. Loop 1 is inside this area, loop 2 is all the way around, loop 3 is in the upper triangle. And if we look at loop 1 and we apply Kirchhoff's law starting at the 13-volt source, we get 13 volts minus I1 times 1 omega minus this current here has to be I1 minus I3 because of the loop rules, the current rules, the junction rules for Kirchhoff. So when M is equal to 0, notice that this is 13 volt. I have minus 1 I1 and another minus 1 I1, so that's a minus I1 times 2 ohms, and then plus I3 times 1 ohm. So a little simplification of what the top is gives us the following. And then let's look at loop 2. And loop 2 is called loop 2 is all the way around. Let's start with the 13 volts. So we have 13 volts again. And then we reach point C. We're on the outside. So we have negative I2 times 1 ohm. And then we come to junction B. Junction B has a current of I2 plus I3 times 2 ohms. And then we're back at 13 volts, so that equals 0. And again, if we simplify this a little bit, we get 13 volts minus a 2 I2 and a minus I2 times 2 ohms, so that's a minus I2 times 3 ohms. So then we have a minus I3 times 2 ohms equals 0. And now let's look at loop 3, which is the upper triangular loop. And let's start at C and go counterclockwise. So we have minus I1 times 1 ohm minus I3 times 1 ohm plus I2 times 1 ohm. This equals 0, and this gives us that I2 equals I1 plus I3. If we take this equation and plug it into the above result, we get 13 volts minus, instead of I2, we have I1 plus I3 minus I3 times 2 ohms equals 0. I forgot to multiply this by 3 ohms. So when we rewrite this correctly, so this would be minus I1 plus I3 times 3 ohms. That's this part, and then minus I3 times 2 ohms. So this gives us 13 volts minus I1 times 3 ohms minus 3 I3 and a minus 2 I3 is a minus 5 ohms times I3 equals 0. Now notice that the first equation, if we write this as 13 volts minus I1 times 2 ohms plus I3 times 1 ohm equals 0. 13 volts minus I1 times 3 ohms plus I3 times 5 ohms. It should be minus 3 times 5 ohms equals 0. And now we can multiply this one by a minus 5 and add it to the second one. So we get 5 times 13 is 65, negative 65 volts plus 10 ohms I1 minus 5 ohms I3 equals 0. 13 volts minus 3 ohms I1 minus 5 ohms. It should be a positive 5. Sorry folks. Because I3 equals 0 because we want them to cancel. So this gives us 78 volts minus 13 I1. Those cancel out, equals 0. So I1 equals 78 volts divided by 13 ohms, which is 6 amps. So we found I1. If we take this and plug it back into the equation, 13 volts minus I1, which is 6 amps, times 2 ohms, minus I3 times 1 ohm equals 0. Gives us 13 volts minus 12 volts minus 1 ohm times I3 equals 0, or that I3 equals 1 volt over 1 ohm, which is 1 amp. So the total current actually would be minus 1 amp, right? Yeah, minus 1 amp. Total current then we know is I, which equals I1 plus I2 if we look at I1 plus I2, remember that I2 equals I1 plus I3, which is 6 amps, plus a negative 1 amp, which is 5 amps. So I1 plus I2 is 6 amps, plus 5 amps, which is 11 amps. And if we wanted to do the equivalent resistance, then we know we have the total current, the total voltage. We can say that the equivalent resistance is the total voltage, which is 13 volt, over the total current, which is 11 amps, and that gives us 1.2 amps.